Okay, 15. We have 2-point charges. Charge 1 is 5 nanocoulombs. Nano is 10 to the negative 9. You're going to punch that in as 5 times 10 to the negative 9 coulombs. And then we have a second charge, negative 3 nanocoulombs. That's going to be negative 3 times 10 to the negative 9 coulombs. Separated by a distance of 35 centimeters, which is 0.35 meter. All right, first question. What is the electric potential at a point midway between the charges? So directly in the middle. Now look, I like to point out here, last chapter you learned how to calculate electric field at a point. The equation for electric field is KQ over R squared. Electric potential is KQ over R. Very similar equations. Which one of these is way more difficult to deal with? Electric field. What makes electric field a lot more difficult? It's vector. So like, for example, like what if they wanted you to find the electric field at the midpoint? Because you're going to get questions both ways. Like when I give you the midterm, I could say, find the electric field there. Or I could say, find the electric potential. It's different because electric fields are vector, electric potential is scalar. So look, if we're doing electric field, then you have to go, okay, positive charge, electric field goes out like this, right? So what's the electric field doing at the midpoint from charge 1? Going to the right. It's going like this. It's going out to the right, right? Okay, negative charges, the electric field goes in like that, right? So what's the electric field doing at this midpoint here from the negative charge? Going in. So then what you would do is you would calculate the electric field for both of these. You'd find out E1 and E2, and then what? Add them together or subtract them? Add them, because they both point to the right, right? That's how you would do electric field. So now, let's answer this question. Let's do electric potential. Electric potential is nice and easy, right? Because all you got to do is you take the algebraic sum. You know, so the equation we're using is KQ over R. Notice the Q is not absolute valued. If it's minus, you got to plug it in as minus. So we're going to go K, so this guy's charge 1. It's going to be Q1 over R1 plus K Q2 over R2. You know what I'd do here? I'd factor out the K's, right? Just make it a little bit easier. You could pull the K out like that. Put the K out here. Make sure you plug in Q2 as negative. All right, so this is going to be, I'm going to run out of room here. Let me scoot this over. Scoot this over here. So when you plug in, you're going to go, so K is 9 times 10 to the 9th, Newton meter squared over Coulomb squared. All right, so charge 1 is 5 times 10 to the negative 9 coulombs. Now, what's R1? That's going to be the distance here, which is half of 35 centimeters, which is 0.175 meters, right? That distance is 0.175, 75 meters. Okay, then plus, now this is going to be negative. Let's just put the negative in right here. You guys see what I'm doing? Because this guy's negative, right? So minus 3 times 10 to the negative 9 coulombs. And then this distance here is also 0.175. 0.175 meters. Okay, has everybody got this negative right here is what? It's the charge. It's negative. Okay, so the answer comes out. The electric potential at the midpoint is 102.9. Oops. 102.9 volts. That is the electric potential at that point, at that single point. Does that make sense? Okay, now question B is tricky. Now what the heck are they talking about? They're saying, what is the potential energy of the pair, right? So look, here's the definition for electric potential. The definition for electric potential is potential energy per charge, right? So if you want potential energy, you go like this. Potential energy is going to be electric potential multiplied by charge. So what you got to do is you got to take one of these charges and remove it for a moment. So which charge should we remove? Let's take out the negative. Ready? I'm going to take out the negative. We're just going to erase this guy. And he'll be back. Don't worry. Don't worry. No crying. Okay, he's gone. And all that's there is a point. Now, how far away is that point? It's 0.35 meters. So what we're going to do is we're going to calculate the electric potential at that point from this guy, right? So we go KQ over R. So you go 9 times 10 to the 9th Newton meter squared. I told you this chapter sucked, didn't I? I shouldn't say that, but I can't lie. It's not the most exciting chapter ever. And then R is 0.35 meters. So we get the electric potential at that point equal to 128.57. So this point right here, 128.57 volts. Now, what we're going to do is we're going to bring back that charge that I erased, right? Let's see. How can I do that without clearing everything? Everyone's been drawn. Here he is. Ready? He's coming back. Woo! There he is. Bam, 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 bam. He's back. Okay, now, would that guy have potential energy sitting at that point? Yeah, because look, what's the definition for electric potential? This is electric potential. Electric potential energy is potential energy per charge. Did that point have an electric potential? Yeah. So if you want to find out how much potential energy that negative guy is going to have when he's sitting there, you plug into here. So the potential energy, we're going to go like this. So the electric potential at that point is 128.57, and a volt is a joule per coulomb. This V right here is joule per coulomb, and then the charge is the charge sitting at that point, which is going to be, what is he, 3 times 10 to the negative 9 coulombs. Oh, and he's negative. Put the negative there. So this gives us a potential energy of 3.9 negative 3.9 times 10 to the negative 7 joules. That's the answer to part B. So what you do, you remove one of the charges, take one of them out, find the electric potential at the point that was there, and then stick back the charge that you removed and find out how much potential energy he'd have. You guys liking this chapter? I promise circuitry is much better. Circuitry, it's much more, your brain can grab it much easier. This is kind of abstract. But you got to learn it. Yo. I mean, you could do this with multiple charges. You could have like 5 charges. Yeah, but typically with this question, it's going to be 2 charges. So what you do is take one away, find the electric potential where it was, and then stick that charge back in and find out how much potential energy he'd have. Electric potential is V.